Sure. I'm going to do okay. I saw you had some sample code in there. Yeah. We plan to go over step by step. Okay. You started at high level. Cool. So yeah. You can start. So I'm going to use this mic or because one of
yeah, I think I can use this mic and then try to.
If
you think it's better that one?
If you stay close to that one, then we'll just use that one.
Yeah, I'm gonna try to stay close here. So
okay, and I'll mute my mic. You can start. I'll introduce you and start.
Oh yeah, sure. Go ahead. You can talk here. No, this is where the microphone is, right? Or
yeah.
Oh, okay. Oh, that's okay. Hi everyone. Thanks for coming for the meetup. We are very happy to have Luis Gomez. He's a principal engineer at Brocade and also the lead for the integration project at OpenDaylight. And he's also a technical steering committee member, so definitely you could ask him even beyond just what you see here. He's at least dialed in for all the calls regularly in the past 1 year. So yeah, if you want to know more about OpenDaylight's evolution, where it's heading towards, and more projects are coming on board, and more questions are coming on benchmarking and how OpenDaylight works against other controllers. So all these things are definitely things Luis is thinking about. So we should make use of his presence and ask all these questions.
yeah.
Thank you.
Thank you, Srini, and thank you everybody for joining. Yes, my name is Luis, and I started the integration group in OpenDaylight. I don't know if the audience, the people know about the integration group, what it's doing in OpenDaylight. And probably this is what I'm going to start saying in this conference. So yeah, even before I started this presentation, the integration group in OpenDaylight is currently responsible for put together the distribution for OpenDaylight, whatever is that. The distribution today is made in a container called Karaf. So all the project that goes together in Karaf and the assembly of all that together is what we do in integration group. This together is all that is the system test. And there is an historic reason for this. So when we started in OpenDaylight, our first mission, if I remember correctly, was exactly to create a distribution and do some tests. Do some tests that could be anything because there was no test done at that time. So during the first release, a few people joined the team and they were kind of Java developers, so they spent some time writing some JUnit. At the same time, there were a few of us that they were more coming from system tests and normal QA departments. So we were trying to set up some kind of framework also for system tests at the same time. But in the end of Hydrogen release, we managed to get some JUnit done, yes, and then some system tests very small for the OpenFlow basic features, and that's it. And then we decide that, okay, the next release, Helium, we are not going to do any, at least the integration group, we are not going to do JUnit. This is something that has to be done by developers because they are the better to understand what the Java code is doing. So let's, get developer to write the JUnit, and we still do system tests. That was the strategy for Helium a little bit. But then what happened is, okay, we are very few people in integration. We cannot really do system tests for the projects. And at that time, it was not like 40 that we have now. We had around 20 or something like that, but still too many projects, very few people. So we managed to do some kind of system tests for the controller, for the OpenFlow, for some plugins, but not everything. Then comes Lithium release. This is going to present now. And Lithium release, one of the things I'm going to present is like, yeah, we are not going to do that anymore. So system test is something that we understand to be done also by the projects. So projects now have features. These features need to be tested, and why not? I mean, at the same time that you are doing your development, you can write some piece of system test and also be able to run that. And what are we doing in integration then, this release? We are not doing system tests anymore. So what we are mostly doing this release is, one of the things is setting up the new infrastructure that we have now for dynamic VM. So that was a big change from last release to this one. Before it was very static setup of VM that we have for testing. In this release in OpenDaylight, we have something called Jenkins Job Builder, the same as OpenStack or something similar. Not the same, but similar. And there was so many change in the infrastructure that we spent a lot of time just to deal with that and be able to migrate all our testing jobs to the new infrastructure. The second thing we said we're going to be doing is two things. Focus on something you will hear more, which is the 3SP, which is the stability, the scalability, security, and performance. So these areas that apparently projects, well, they can take care still, but kind of forgotten. And then we also said in integration we're going to be doing cross-project. Like if there is some test that is not just related to one particular project, can imagine like OpenStack or some of the tests that are across projects, why we can do it as well. So this is an area where the integration can spend time as well. Use cases. There is something now very much in the in the mood in the OpenDaylight. Let's come up with some use cases like but that thing that are the use cases, if it is something that is across projects, we're going to be helping testing those things. So that's the integration, responsibility, or at least the thing that we are doing this release. Every release we are changing and we are evolving. And COVID and next release we said, okay, now it's time for the projects to do also performance and longevity and this kind of tests. So why not? This is something that we're going to be pushing to the projects and then waiting and measuring. Something that we do, I was commenting before with some of you, this really we are pretty much in tracking what the projects are doing in system tests and tests in general. We're going to be adding more and more tests the coming releases, and integration is always been collecting the information for the projects, like how much tests, how much coverage, how much quality you have. That's the idea. And it's clear that we can use all this information around for, one of the things, ideas is classify projects, like the same as OpenStack does today or try to do, like projects that are more core, they are more mature, but the same probably we want to do in OpenDaylight at some point. Today we don't have enough criteria understanding how to classify these things, but hopefully now we have more data, more information to start doing that. Any question? I'm going to be, you can interrupt me, but I'm going to be also stopping time to time in case that there are questions about whatever I'm saying. So any questions so far? Yeah, so yeah, OpenDaylight is a project overall, but then when I talk about projects in general, that's the different components of OpenDaylight. OpenFlow plugin, OBSDB, SFC, policies, individual projects or contribution within OpenDaylight. Yes.
You talked about use cases. You said that there are some that were either already decided or...
No. So this is something that we said many times that we want to come up with use cases. There is pretty much an idea what will be the things that we want to focus to start with. One of them is clearly OpenStack. I can say clearly now. Another thing could be a service chaining, because it's a very much a use case for operators and so on. But yeah, where the description of the use cases will come from? Well, this is something we need to discuss in TC, to be honest. So there is a request now that we need to come up with use cases really, and this can come from the TSC itself, or TSC can say, okay, projects, is there any project that can do this work to come up, or some people volunteer to write down these use cases and review them and share with the community? Yeah, we can do that as well. But at this moment, it's a little bit like that. I don't expect, what I really would like is to see these use cases somehow documented at least in terms of use cases, like, okay, and not only use cases, I mean, the first thing they use case, but also test cases. Like test cases, like take the OpenDaylight, connect to OpenStack, now spin a VM, now a hub, and now make sure that the transport works. So that kind of thing I would like to see as well. And once we have that, not this release, but maybe by next release, we can say, okay, which projects we have today in OpenDaylight that they can pass so they can fulfill these use cases, test cases, or whatever we have. That's the idea. Hopefully, yeah. Any other question? Yeah, there is a lot of things there, yeah. There is a draft state, and you can do service chaining in many different ways, as you can understand, using open flows, using OBS DBs, using VSLANs, overlay. I don't know. There are many ways to do it, and I think the final idea or the sense that I have is whoever is going to write the use cases is not, hopefully, I think it's like that, is not going to focus in one particular technology. It's going to say, okay, I spin my VS, I do this, and then make sure that works. Now, how that works, if it is via overlay, OpenFlow, that is responsibility for the projects to figure out, and maybe for projects, hopefully, that they can claim, the four of them, hey, I can do the use cases, the test case that you are asking me using this or that technology. That would be awesome. But let's see if we can get there. That's the idea, I think. And of course, there is something else, probably we are more far from that, is to be able to combine plugins. Like today, we have plugins in OpenDaylight, and maybe use this or that plugin to achieve the same. It would be awesome if in the future we can use a combination of plugins to set your path, your transport, whatever you want to do. More complicated when you are doing multi-plugin for sure, but why not? We can dream, right? Any other question? Cool. So this is what I presented in TWS. I don't know if people are familiar. TWS is one of these calls that we do in OpenDaylight to share technical knowledge. It's every Monday, and I think it was like a month ago I presented this to the to all the people in OpenDaylight. So this is just more or less the same. If someone was there, yes. So let's go. So this is a little of the fact that we have in OpenDaylight today. OpenDaylight projects are quite heterogeneous, platform, tools, plugin. We have people may think that the projects are kind of similar in OpenDaylight, and that's not true. They're actually very different. Projects normally define one or more features. We have to test them individually and together. Yeah, that's also important. Because, some project that is a library or is a tooling maybe doesn't feature for a user. So maybe we are not that interested, but some other may expose 3 or 4 features because it's an application that is very much used in different ways. So we need to test all these things. Another challenge that we have, facts or challenge, I don't know how to say that, is that, today, in the beginning, the first release, we have a fixed distribution that you just bring the distribution up, and then you have something running and totally doing something. Now, since Helium is like we just have a free distribution where by default doesn't come up with anything, and then all the features are there, but you need to manually enable these features. So you are interested in OpenFlow, you bring the OpenFlow. You are interested in OBSDB, Netconf, whatever feature you want to use, you need to enable individually because it's like that. And we like that model very much for user point of view because it's really it's really flexible and allow user a la carte kind of selection, but it's a challenge, as you can understand. So how are we going to test something that is not rigid, that is totally flexible? So yeah. OpenDaylight has a common CI process. Yeah, this is well known. We have a continuous integration process where people are patching continuously. They are verifying, and then they merge. And we need to deal with that. And whatever test we do, we try to do in the continuous integration because this is where things make sense. Number of projects, and this is probably the most important, is the last one. I mean, when I started, it was around 10 projects. The next release was 20, and now we are 40 plus. So it's like, apparently every release we're increasing in a way that we need to adjust our continuous integration, our test, to this explosion of projects. Any questions so far? Cool. Oops. So yeah, what is this? High-level strategy. Yeah, this is a little bit the high-level strategy for this release that we said in the beginning. Instead of verifying projects, which you don't know what they are doing, what we want to test really is user-facing features. So if a user has the ability to enable or disable something, let's test that, regardless of which project is behind. Now, because of the nature of this distribution, that can be one thing or many things, I mean, it's up to the user. We normally test the single feature itself, and this is what and the same feature we test with all together. So that way we make sure that the feature itself works. And second, if this feature is brought with a lot of features still can work. So that's a little bit the strategy we have today. I mean, we cannot test everything in all the possible combinations, but at least for every feature we make sure individually works and also in combination of others. Now, for a given project, how often we test? Well, we test every time there is a change in the project code. That could be a submit of a merge. In these two situations, we are doing some kind of test. We are also testing whenever there is a merge in the upstream, and that's normal, no? If you are depending on some project, and some project in the upstream is changing in the OpenDaylight, you need to retest yourself to see that your application still works. So that is common sense. What is new, and it was doing this last release, so this is nothing new this release for that. This new this release is that we try to do selective or selection of which test we're going to run, depending on the project that generate the change. Like in the last release, if I remember, is any single change, no matter which project in the OpenDaylight, we just run all the tests. All the tests, it's not many anyway, but we run all the tests. And now this release, we have a strategy that from the beginning that says that doesn't scale. So what we're going to do is, depending where the project is in the change, in the upstream or the downstream, we're going to trigger this or that test. So if you change something very much in the upstream, that is going to trigger a lot of tests. If you are changing something in the more in the downstream, like a leaf project or something that we said in OpenDaylight, that is going to generate only very few tests for the concerning application, and that's it. So that's the strategy as well. And the most important thing that we change this release is projects now are responsible for their own system tests. So we're going to be helping, of course, integration, always support people, robot, whatever, but we are not responsible anymore to write system tests for any of the projects. That's now project responsibility. Any question? Cool. Distribution, yes. So distribution, this release has changed a little bit compared to last release. Distribution in this release come with two features, two integration features. It comes with a lot of features. All the projects feature come in a distribution, but there are two features that we create an integration for testing purpose. One is called the compatible with all feature, which is very useful to test feature with other features. And then there is something that we call all, which is exactly is all the feature together. Now, these features are only for test purpose because we have a scenarios where we want to bring a lot of features all together and see it doesn't explode. But in general, we don't want user to enable these things. So that's why this feature, you cannot find this release available. You need to enable them. They're kind of hidden. You need to do some command to import the repository for this. They are in the distribution, but it's not right away. You do feature list. It's not there. And the reason is because we did have some issues in Helium. This is all because of reasons that people, they see OpenDaylight, compatible all, or this is the feature I need to use. It will bring up whatever I need. But of course, if 40 projects, you bring all the projects together, you can imagine the RAM and the CPU and all the things that you need to run that. So yeah, that's something that doesn't work. So that's why we decide to remove this test feature from the distribution. Oh, this is the most interesting part. This is the CI infrastructure today, how it works. It's all in this diagram. For a particular project, you need to think in this diagram what happened with a project in OpenDaylight, one of these contributions. How does this really work? So how this really work is that there is some events that you can see on the left, and the events are coming either for Git get rid, which is the code management tool, whenever someone submit or merge a code. The second is whenever there is a change in the upstream. This is what I told you before. We trigger builds and tests whenever there is change in the upstream. So with these two events that you see on the left, there is the first thing that happens is a project build. So you're going to build your project, and whenever you build your project in the system, wow, you are going to run also a test with that. All the JUnit, access some tests that we will see later. All this happen at build time, right? And then, of course, we have something called Nexus, which is the repository in OpenDaylight that retrieve all the artifacts that you need to build your project. And then once you are done with your build and everything passed, then you upload the artifact back to Nexus. This part here was before project responsibility, and this part here was integration. But now it's called project, because what happened is now when the project builds and, when the project merge and upload artifact to Nexus, we call a distribution job that is already in the project, and thus create a new distribution with the new component in Nexus with the change done. And then what we call is the system test. So there is a distribution build, and then there is a system test that is happening also whenever there is a merge. So that is the how things work today in OpenDaylight. And one of this is also very new and using all the dynamic environment now. Something that we are trying to do this release to measure the delay of all this. Whenever someone merges a code, how long does it take to build everything, and then to build a distribution, and then to pass the system test that is appropriate for this particular merge. So we are trying to monitor all that, and hopefully, yeah, we're gonna get something. But this is pretty much how things work in OpenDaylight today. Any question on the? Yes.
So this is only for the testing the feature with all the other features that impacts.
This is sorry. No, yeah, sorry. So part system test that you can see here, I think I got you now. The system test is divided in two, and I think this is coming later. The system test is divided in two. There is one system test for a particular feature that runs on the single feature test, and there is another one that runs with all the feature. So the system test today contemplate these two scenarios, single feature and multiple feature. The system test also contemplates today in-memory data store when you don't have any cluster, or when you enable cluster as well. So you have this kind of difference as well. But the system test is really flexible, much more than JUnit, in my opinion, in terms of how you run things. Like the environment that you run your system test can, we can even test with different OSs. We can test with things that whatever you have in mind is possible with system test. And I will spend more time in system test by the end of this, the third part of this presentation. So this is, again, to say, every time we build in OpenDaylight, there is a build test. This build test is basically the JUnit and the passes. Every project in OpenDaylight defines 3 build jobs: the verify job that runs every time there is a commit, the merge job that runs every time there is a merge, and then there is an integration job that builds every time there is a merge a change or a merge in the upstream. So these are the 3 basic jobs that you will see if you go to Jenkins in OpenDaylight today.
Curious, do you know how often people get stuff and how often it gets kicked up?
Well, yeah. What I can say there is that there are some projects that commit a lot, and this project also, they have special days to merge. Like you can see Controller and Jan Tools and some of these projects that they are doing a lot, and they can push Monday, Tuesday, and Wednesday, the first days in the weeks, they push like maybe 20 patches every day. So a lot. And it's not only that they have a lot of people there doing stuff, but also they are waiting. They prefer to patch in the beginning of the week, so if something happens, they can fix the rest of the week. They have this strategy. The rest of the projects, normal leaves, this is the difference between a core project like Controller, Jan Tools, or a leaf project. The leaf projects are less frequent. So it could be 2 or 3 patches a week, 3, 4, 5. It's not really like depending on the time as well. Something that you can realize is for cycles. Some cycle when you need to freeze your API, or you need to freeze your code, or you need to freeze your functionality. So we have milestone, right? So it usually happens that projects, when the milestone arrives or is closed, they speed up and they do more patching than normal time. So that happens as well.
And each of these components, they all run in on top of each other or something?
When you say this component?
Do all these, the Jenkins, the continuous integration
Yeah, so this is very good question. So today, all that you can see here, the project, the Jenkins, Nexus, Git, Gerrit, all these components are VMs. Are VMs in the rack space. Today we use rack space. Before it was Linux Foundation kind of infrastructure, but today is rack space kind of. And there is the good thing is that before everything was static, so Linux Foundation is 50 VMs, whatever they need for this. But now it's totally dynamic. So what happens is a contract where you buy CPU and memory, and then you spin up VMs as you need, which is very dynamic and very cool. If I have more time, I will explain how this works today because it's really cool how it works today. You can, so it's very dynamic. The only thing is that, okay, because it's so dynamic, now you need to wait some time to spin up the VMs. It's not like before, the VMs are there, ready to use. So there is some delay when you are with the VM that needs to come at the VM. But other than that, I mean, it's awesome. I mean, other than that, it's like you need 10 VMs for your test, 10 VM for your test. You need 20, whatever you need, you have. And that's the way this can scale.
So the upstream project with there, is it a third-party jar file that OpenDaylight depends on?
So these ones, the upstream is actually all OpenDaylight. So the upstream is all that is OpenDaylight. Like if you are sitting in a project in OpenDaylight, you depend on these YAML tools or controller or obvious DBs. So that's the upstream project we have today. Of course, we have some upstream that could be Karaf. We are consuming Karaf. We are consuming third-party component. That could be an upstream as well. The only thing we are doing there is a project called ODL Parent. I don't know if familiar people in OpenDaylight. We have a project really in the root of OpenDaylight that is ODL Parent. And this is the project that maintains the version for all the third parties today. So if someone said, okay, I need a new version on a new version of this particular third party that we don't know OpenDaylight, they go, they patch there, and after that we trigger all the tests to see, okay, is an impact or not, or what happened here. But yeah, that's the way it is. So yeah, we have some dependencies upstream in that sense, third parties, and we deal. The only way we deal is if someone feels the needs to upgrade that, we do upgrade, and then we launch all the tests for that. That's the way it is. What if the test fails? Well, depending which test. That's a good point. So if there is a build test, we said that this is the build test. The one is planned. Normally, if a build test is gonna block everything. So if you, for instance, are building your code, it doesn't build for some dependencies, and just stop. It just fail, red, and stop. So you need to fix your code. You need to fix whatever it is so that doesn't go. If there is because you have tests as well, if a test fail, it's also fail your builds. So if you have a fail in a JUnit, still you have a fail, so you cannot pass. And what happens is if all this is in connection with Gerrit, at least the verify and the merge are in connection with Gerrit, well, especially the verify. So if something happened that you fail the build, then you cannot be merged. Basically, you cannot be merged. Even if a committer wants to merge your thing, it cannot in the system because it failed the build or it failed the JUnit. So that is not possible. Now, the second question is what happened with the system test. And let me explain first what is the system test, and then I answer your question. What is the system test? System test requires a distribution. So system test cannot be done in a VM. I need a distribution of OpenDaylight, not just a piece of code. And normally, I need an automation that installs this distribution and normally executes some tests with using network tools, because this is an SDN controller. So yeah, you need some simulator, mininet, whatever. So, and this is for the question as well. So every project in OpenDaylight will define two jobs. One job, this is the distribution job, which builds the integration code, and therefore you generate a distribution. And the second is the system test job. And the system test job, for every project user-facing feature, we will create two system tests. The one I mentioned before. One is the feature-only test that only brings the feature individually, and then the feature-all test that brings everything all together. So that's the strategy that we are following together. Now, how many of these distribution we have today? Distribution jobs, we have one per project. So every time that a project does a merge, as I explained before, you generate a distribution and then you test. Now, how many system tests you have per project? Well, depending on how many user features you have. A project with one user feature is just one, two in this case, the single and the all. If you have like 3 or 4 features, then you have more system tests to do. And some projects, like because they don't expose any user-facing feature, they just don't do any system tests, and that's normal. I mean, most of these projects that are in the root or in the core, they don't need to maybe do system tests right away, because by doing system tests later, I mean, you also prove them. So it's not really that you need to do tests there. You can do later in the chain. And because of the way we are triggering tests that are changed in the upstream, also, yeah, kick off the system test in the downstream. You don't really need to test these tests themselves, but also with the upstream. That's the way it is. For your question, so today system test doesn't block. So today system test, you can get some fails, and still everything goes as normal. Now, what happens is that the integration people, at least we feel a little responsible, at least this release. So we are monitoring this system test, the result, and see, okay, this system test now regression. So let's send a mail to the project and there is a regression. Something that I also try to do to release before all the system tests was integration, Jenkins, repository, everything in integration. Now, all the system tests are in the Jenkins in the part of the project. So a project, when it goes and look the job that it has, it can see also the system test. So they can also act and say, okay, now why this is failing that was working before. Or, I mean, we try somehow to make the project responsible as well for the system test. And this is one of the things but today we are not blocking that. And yeah, I can see, one of the things we could do is to say, okay, the system test fails and don't upload artifacts or something. But we have seen situations in the past where a change in the upstream produced some error. The error was not because of the upstream. The error was because the downstream has some issue that was totally covered or hidden. And when they change something in the upstream, now the downstream is failing. So that's why we don't want to block things just because of the system test. But still be aware that, yeah, I mean, you need to fix that. If that is failing for a few days, you need to fix that. And we are pretty much doing that in integration, also sending mails here and there to say, okay, fix your system test. Of course, we are a little bit of relaxed during the development cycle, like, okay, you can have your job failing for a while. When we approach the release, no. When we approach the release, we're going to be very serious there. Okay, fix your system test because we need a very stable system test to test the release candidates and everything that comes by M5. So, yeah. Any question? Cool. Okay, also interesting. All the test triggers that we have today in OpenDaylight. And this is a little bit to say, let's start from the bottom, and this is also clear. Whenever we create a release or release candidate, we're going to trigger for all the project that we have. We're going to trigger all the feature only and the feature all test. This is very easy to understand. Whenever there is a code merge, and this is in place today, we do a merge build. Then we do an integration build for all the projects that are in the downstream. And then, of course, we trigger a distribution build. And that distribution build is going to kick off system test for this particular build. Plus, I'm going to kick off test for the downstream. So this is all that happened today when there is a code merge in the system, another way to represent this. And the thing that you see on top is the thing that never existed before. In OpenDaylight, in the last releases, when someone commit code, the only thing you could do is a build test. You could never do a system test because of all these Jenkins silos and the static thing that we have in the past. But now with the dynamic environment, we realize that it's possible to kick off also system tests after someone commits code. And you may say, why I need to do that? Well, we have a few story situations where some commits or merges in the root, in the Jan tool, so the controller breaks absolutely everybody. And then after that, it's difficult to say, okay, how to revert that or where is the problem? So in the end, these people from the core, they have a way before they merge to verify that the patch doesn't break everybody. That is really useful. And this came actually a request from these particular projects where they say, okay, we want to get a way to verify a patch before we go and merge it. And when I say verify, it's the system test, which can take maybe 2 hours. Or I think 2 hours in the last release. In this release is much less because of the dynamic environment. But it's non-test compared to just a single build test. But still, they want to wait and see because some patches, they know the committer that can hurt people. So that's why it's very useful. So this is something totally new, and I'm going to release the job is almost ready, the job for doing this. I'm going to release it this week. And then what the idea for this job is today is what I prepare is a manual that you just get the Gerrit rep spec. You put the Gerrit rep spec or the patch ID, and then it's going to build the patch and then build the integration and then pass all the system tests. What I'm going to be doing later with the help of the Linux Foundation is to use Gerrit. So when someone patch something, if they put the committer or the contributor, if they just put in the mess of the commit, automatically it's going to trigger all these tests. So that is another possibility we are thinking. Cool. Any question on this? And then quality, but this is the last one I have. This is something that we discussed. How are we going to, we have a lot of things now coming in integration of the projects. How are we going to measure all this? How are we going to see how projects are doing in terms of tests and continuous integration? So one of the ideas that came, we meet together, and some people were there, is it's very important to get the code sanity and code coverage reports collected in Sonar. So that's something that Sini will tell later. So whenever you do JUnit or this kind of report to Sonar, so we can see there how much of the quality you have. There's another thing we can do in system test, because the system test is going to be stored in the integration repository. We can monitor or track how many test cases. Well, you can also see in Jenkins, but we can also track in our repository how much the system test the projects are doing. The third thing we're thinking is things that we need to monitor for quality is also the bugs that we haven't really monitored that much. I think the only way we do this is whenever we're going to release, we ask all the projects to say, okay, do you have a critical bug now that we are going to release, or some important bug you need to fix? Let's know how critical it is. Instead of that, what we want to do is a dashboard. We want to do a dashboard, this release pretty much, and say, okay, but what are the trends? How many critical bugs you have today? How many are you fixing? So these kind of things we want. And then something also new, and we'll have more question later, is about performance. Yes, we haven't done much performance in the last release, but this release is coming like a priority, and you heard now the TSCs and the board discussing how we're gonna get some performance, scalability, stability gain into the OpenDaylight. That's the idea. Any question? Yes.
Maybe it's a very basic question, but so what do you mean by project and downstream? So
yeah, so this is for a given project. This is a little bit the other way, no? If you have, let me think about this. When there is a code merge in a given project, that produces a merge build in its own project. But when you merge in your own project, everything that is in the downstream, you're gonna generate system integration build, which is they're gonna build to make sure that the build is still okay after your change. Plus, you're gonna generate in all the downstream system tests. So this is to say there is a code merging controller today or in Jam Tools that is going to produce its own build, but then whatever is depending in the change is going to build again, just to make sure that you can still build. And then it's not only that you're going to build, but also you generate a distribution that you're going to test completely in the downstream. This distribution that you create in Jam Tools is going to be all the way tested in the downstream. So that's the way it is. Yeah, it's a little bit the other way of the other one that I saw before. Sure.
So in the question actually just thinking of the system test, so for the plugin project we test on Meetup,
yeah.
The system test. So do the developers make the system test and the project?
So for OpenFlow plugin, what happens is yes, we use Mininet for that. But the thing is that in the Hydrogen and also in Helium releases, integration group was doing the system test. And this release, what happened is I asked the OpenFlow project, okay, this release you are responsible to do this. And they were lucky because there was someone in the integration group that actually volunteered to become the test person in the OpenFlow plugin. So because of that, they are kind of, and it's good because there are very few people now in OpenFlow plugin, really. So it was kind of handy to have someone in integration volunteering to do the OpenFlow plugin test, kind of this release. So I don't know. But in general, for the rest of the project, they should come up with a test figure. We asked that in the release, like you need to name a test contact. It doesn't mean that this test contact in the project is going to do the test himself or herself, but it has to be responsible for testing. So if I say, okay, why you don't have any tests in the release? Well, they have explained that somehow. And today, to be honest, I don't know how this is going to end up. We said that all the projects need to come out a piece of system test in the system. If you feel that you cannot do system tests in OpenDaylight because you have a tool that cannot be in the VMs or something that cannot run that way, or it's very difficult, all this continuous integration, you can still do your tests in your lab, in your whatever you have in your laptop. You can do that in your laptop. But something we said this release, every time we produce a release candidate or we have something like that, you need to come out with a test report. Yeah, so you can do your own test, but then we're going to ask you some test report, some proof that, yeah, tests are passing and that kind of things. But you can, yes. So we'll see. This is all very new, so. Nexus? So Nexus is just the, I don't know if there is some confusion here. Nexus is just the artifact repository in OpenDaylight. It's just a tool that you put all the, whenever you build something, whatever is the artifact that you built, is going to Nexus. And then this can be used by other projects in the downstream. Like you are controller, you upload one artifact, and then the people that are in the change in the downstream, they can use that artifact to build.
This is all maintained by Linux Foundation.
Yes, pretty much. What's the question? The what? Results. No, the test result today, yeah, the test result today, the best place to see that is Jenkins and Sonar. For all that is the unit, you can see Jenkins, but also Sonar, there is reporting. For all that is system test today, is only Jenkins. So what happens here is that you use the robot framework to run your test, and everything gets reported back to Jenkins. You can see post-test results, everything gets in Jenkins. And I can show you very quickly if you want to see this. Let's see if I can make this small. Just very quickly, we have finished the first part of the presentation. What I'm talking here. So this is all the Jenkins in OpenDaylight. Today, everything is combined or should be working in Releng, which is the master Jenkins silo. Hopefully it's not very slow. Come on. Yeah. So sometimes, yeah, there you go. So this is our Jenkins in OpenDaylight today, which is huge because everything is in a master. And if you take one project, let's say some project that has system test today, like for instance, OpenFlow, what is it? Or layer 2 switch, whatever. So you can see all the jobs that you have today. Some of the dailies are just daily tests that you have. But basically, the one that I was mentioning before, you have the merge job, which is going to merge a patch in master or stable Helium. After that, you kick off a distribution. And after that, you run some system tests. Test OpenDaylight is this format. The project, continuous system integration test. This is the environment that you are running your test, which is one node in memory data store. This is the feature, the functionality under test. This is if you are running with all the feature or you are running single feature, no feature. And this is the branch. And now if you open one of these, you can see the report immediately here. So that's the cool thing of the robot. You can see the report here. Like, okay, how many test cases? And not only that, you can see a graph here, hopefully, it's open. So you can see your test. This particular test has been not very good. It was working at some point, but now you see. So yeah, this is one of the things that one of the people are working now to get all these restored because there are some issues. And then if you go to here, it's not only the report that you get like that. but also you can go in detail. That's the cool thing of robot frameworks. You can go to the log, and then you can see a detailed report, test case by test case. If something fails, you can go exactly here in the Jenkins and see what is failing. And that is the reason we recommend robot framework, because it's really a test framework. It's not just a script or something. Yeah, take some time. So the tools and infrastructure is Linux Foundation, OpenDaylight. But then, of course, if something fails here or there, the Linux Foundation is just infrastructure people. So if something fails here, the people that goes and check what is failing is the integration people. So I can go here and say, okay, the loop test is failing. So what's going on? Right? And then you can get here, open. So okay, in this printout, this particular word, which is forwarding, is really, it doesn't contain 4 times. So something is failing here. And I think I know with this problem. Like someone put some application in the inventory now that is also adding this kind of forwarding labels. And because of that, now this test got broken. So we just need to go there and repatch it. But yeah, this is the kind of thing that is cool. You have a full, complete report for test case by test case. And also, if there is a failure, you just need to open here and say, okay, this is why it's failing, right? And this is also the framework that we are using in Robot that I will talk a little bit later. It's using a high-level language, like something is contained. I mean, you don't need to know, Java, Python, or even scripting. I mean, everything you need to know is the libraries that are in Robot, which today is a lot of libraries there. And then you just use the keyboards and the words to write your tests. It's really easy and handy once you know how to do it. Any question? Yes.
If you already have an instance of thinking, does this integrate with that you have to have 2 separate?
So Jenkins, before in the past release, every project had its own Jenkins master, if you know how Jenkins work, and they don't talk each other. So it was very difficult to say, okay, whatever I merge here, now call a test here. Impossible. So what we did this release is to combine everything in the big Jenkins that I showed you before. And now it's a single Jenkins master, which is this one. This is the Jenkins master. And then what you have is slaves. You have a lot of slaves. And these slaves, let me show you, they are created dynamically. So you can see here, let me go back to the Jenkins main. Here is what you can see now. So now there is no builds in the queue. Here you can see, but these are all the dynamic VMs that they automatically created and destroy dynamically. It's dynamic, but there is some intelligence here. Like, for instance, if a VM, you just spin a VM for building or for doing some tests, VMs get reused in less than 30 minutes or something. You don't need to destroy them. So it's keep alive for some time in case you're going to reuse it. But it's true that after some time out, the VM completely destroys and you need to create that again. It depends how much software you put in these VMs, but it's around, I think the maximum I have seen is around 5 minutes to bring up completely your VM with all the software that you need. And then after that, you can use it. Another thing that is cool of this system, everything that is in the VM today, in the dynamic system, everything that you put in the VM itself is part of the Git. So you can go to Git and patch it and say, okay, I want this VM to come up with some software that I need for my testing, and it will. So that's really cool. So yeah, that we don't have last release, for instance. Last release with the static setup, we have to open a ticket to Linux Foundation, and then they take care to install the software. Now, if you go to Git, I can show you quickly where these things are if you are interested quickly. But today, you go to Git, there is something called there is one of the project that is called Releng Builder. This project here. Now branches, Git web. So this project has something today that is like this. You have Vagrant because they use Vagrant to spin up these VMs. So you can go here in Vagrant, and then you can say, okay, what is this exactly doing? Mininet VM, for instance, that you're using for testing. The Mininet VMs, if you go to Bootstrap, you can see all the software that is being installed in the VM. And you can go here and patch it. I want to have another tool to test or whatever. And you can do it now yourself. Of course, the Linux Foundation are the owner for this repository, so they're going to be still reviewing your patch, but you can put whatever software you want. I mean, that's really, really useful and handy, this release, as you can see. Any question? Okay, so then I think your part, I'm going to open this one, right? So I'm going to do the same as before. I'm going to put you in the something like this.
All right.
I just need to go gear down, up and down, and then we'll.
Okay. Okay.
Thank you.
Thanks, Luis. So he's been talking about the bigger picture of where the integration project goes and the whole overall system testing and how you test across projects and how you prepare something ready for the release and things like that. I'm just going to spend maybe 20 minutes, 15, 20 minutes on just the developer's view. So so these days, going forward, really, I mean, in those days in Cisco and Juniper, I'm sure there were huge QA teams. There was a quality assurance group and testing groups and large groups dedicated for writing just the test scripting and testing products. But gradually, as we move more and more into software and networking starts doing more software, we're going to really have developers themselves write a lot of the testing stuff as well because they understand the code, they know what to expect. They should also write some level of testing so that eventually the integration project can come and put it all together and see how it works as a combined project or a combined release. So there are a lot of frameworks today in Java for actually doing these testing. I'm not going to go deep into this. I'll send a link to this slide deck in the Meetup group. But I just want to give you a high-level flavor. So essentially, the goal is considering integration project does a system test and provides, in some ways, a black box testing of the overall release. We need some white box testing that actually tests individual functional pieces to see that you actually are getting what you wanted. And also, it could integrate with Jenkins. If, let's say, there is a test that is failing because one of your colleagues made a change that is conflicting with some other bundle or some other class you maintain, then it's something you can catch, and you can ensure that the check-in doesn't go through. So primarily, I mean, JUnit is the most common testing framework folks use, and this has been there for a long time. Most people who use Java are probably familiar with this. And it also has gradually extensions now to using PackExam and other things to be able to work across multiple bundles and things like that. Not only just multiple classes, but also different bundles and on top of OSGI, work in Karaf and stuff like that. And there are also other frameworks like the mock frameworks that let you make your testing even easier and more specific targeted. Let's say you have two classes you want to test, and you really let's say one class has a dependency on the other, then you could almost even mock the other object and not actually run into any challenges the other object may actually produce. So when you want to test something, you only test that component and not have other components effect also come in. So a lot of these frameworks are there. But JUnit uses annotations for specifying exactly what is a test and what is the code you run before a test and what you run after a test. And also you could also run a set of functions or some code before all your tests, and you can run something as a cleanup after all your tests. So there are a lot of these annotations, right? So it's almost like you write a Java class, just like how you do it. You put it in source test Java, and then you write your code with annotations, and basically it's going to load the classes that you wrote in the main, and it's going to test every functions in the main. And the more functions you actually touch and you test, your code coverage will improve. And this is where the quality of software really comes from. So in OpenDaylight, we use Sonar, and we check how much code coverage every project has, every class has, and things like that. I'll show you an example shortly. But code coverage is something very important so that we have good quality software. So it picks up, so there's another plugin, I'll talk about that in a second, called Jacoco, and the output of that is what Sonar picks up. And this plugin you compile and you run along with your regular JUnit, and it takes the output from JUnit. So it tracks, I guess, all the, it's more on a function level, but and a conditional level. So I'll show you an example. And these are the 3 Maven plugins we use in OpenDaylight. The first 2 are for JUnit. The Surefire plugin is essentially what you run when you want to run a test without worrying about cleanup. So if you want something that basically, if you're running a test and if the test fails and you want to just stop the build right away, you use the Surefire plugin. And you would use the next plugin, it's the failsafe. If you have multiple tests you want to run, and if one of them fails, you still want to get to the other test and understand exactly how many tests. And I mean, the merge will still not go through, but at least the build process will continue. It will test everything, and you'll be able to see exactly what went through. So for that, you use the failsafe plugin, and it will look for all the file names that end in IT or start in IT. And there are 2 goals here, Maven goals. You could specifically run just the integration test goal, or ideally, it's actually a better idea to run the verify one, because that also will do a cleanup. So you run the failsafe verify goal, or if you make it just part of your build, it will run it automatically. And this you could use for testing multiple components, and typically, I mean, JUnit can also be used for just testing one class or just a few functions in a class. So you have different granularities in which you can do your testing. And the last one is actually very important in the OSGI context. Let's say I'm running an OpenStack a network virtualization test. I need to load the OVSDB bundle because it's going to talk to some Open vSwitch. I need to ensure that they all work together. And that kind of a cross-bundle integration, and any testing that needs multiple bundles, you would want to have PaxExam also enabled and put in the right appropriate annotations for PaxExam. And there is some extra stuff you need for PaxExam, which is, I have some high-level description here. It's just a small snippet of code. It basically needs this one chunk here called the configuration. So anything you want to do with PaxExam should have this configuration, so that it will know exactly what other dependency bundles you want to load, and also what other bundles need to be injected as part of the dependency. So all this you need to specify as part of PaxExam. And then after you specify that, everything else is same as the JUnit. You can do your test, you can do your cleanup, you can do whatever. Any questions? Yeah.
Go back one slide. Surefire. So you're going to run
after it's part of the build, but after the main Java, if let's say I have a bundle, I usually have the regular code and the testing code. So this is after the regular code is compiled, the testing compilation starts.
Okay, so you got that regular code.
Yeah.
The Jenkins process, right?
Yeah.
And you kick this guy out. Surefire failed because of that problem. And basically, are you leaving artifacts around some investigating problem that you want to use it?
So you'll have the output in Jenkins. You can go look console log in Jenkins. You'll know which test failed. But the artifact is not generated. Artifact actually only produces after the merge happens. And yeah.
Because why would you use Surefire? Great, right there. I mean, what's the use?
If it's something that is, I mean, if it's a very critical piece of code that is also very everybody else is going to depend upon, like a library code, for instance. For instance, OVSDB project has a library. Yeah. You don't want to move on and you will stop right here. And sequencing of these tests are very important. It's going to serial. It's going to go serial based on how you list it in your test class. And this is something pretty cool. It's been it's a more recent thing. Basically, if let's say I have a class that depends on another class, and I really want to only test this class A and not really have too much things to worry about class B, then I can actually mock a class and provide it to my test unit, and it will help me do the testing without actually worrying about the other class. So sometimes you don't want to construct the other class and get it to the right full state for you to do the testing. You can actually mock a class and ensure that the right callbacks are happening. So this is more for verifying if the right callbacks are happening, the number of times it happens, and any other interface communication between two classes. You would verify that using this. I have a more specific example with OpenDaylight. This is probably not too visible. Okay, let me try this one. Oh, sorry. Yeah, let's go back. Anyway, this. Oh, it came first. Okay, never mind. That's fine. Actually, let me try that again. I think it'll come back.
Yeah, it will come back.
Yeah. Second.
Yeah.
Okay. So, so here is an example. Even if it's not visible, I just wanted to focus on these 4 steps here. So I do some initialization of creating these mock classes, and then I set up some data which is relevant for my test, and then I create mock objects, and then I specify exactly what should happen if a certain call happens. Let's say I have a mock object called data change event, and if someone were to call the data change event get updated operational data, then I would say exactly what needs to be returned. So I almost craft my request response in a kind of a fake way. It's a mock object where you don't actually create the full state. You're just creating the callbacks. So whenever someone is going to do a callback, you know exactly what's going to be returned, and then you can later verify if the number of times that interface got called and things like that. So it's almost where you basically already know what to expect, and then you're running the code to see and verify that that exactly is what happened. And there's another library. This is called mockito, and the other one is EasyMock, and they both kind of work similar. EasyMock actually has a more strict regulation on how you do the recording of exactly what sequence of steps will happen. But yeah, this is for making your testing a lot easier. And this also helps ensure that if, let's say, there is some bug in any one of those classes I'm mocking, I don't have to run into that yet. I can just test my class without running to that. Yeah.
Is there any standards to what needs to be followed? Because not every developer can use mock-based or easy.
I don't, unfortunately, think there is one yet. There are projects like OVSDB project uses Mockito. I've seen other projects that use mock. The MDSAL code base uses Mockito. Yeah, I have not seen a specific standard. And also, there are also ways in which, I mean, do I do the basic JUnit? Do I use do I use something that, I guess, depends on whether I do multiple bundles. So it all depends on what your needs are, and eventually it comes down to just personal preference. So yeah. And so essentially, the output of all these tests are generated in certain reports. Like for Surefire and Failsafe, there are reports that get generated. You can specify the location of that, and this plugin called Jacoco is going to pick that up, and Sonar will pick it up from that when it's doing the build process. So here I have an example. Maybe I should just go to that link. I just randomly picked a project. Let's see.
It will come. Yes, as well.
Yeah. Then what I have here. So essentially here in the screen, this is specifically for one of the files, the OVSDB connection service, and it says how much line coverage, how many functions are covered, the overall coverage for conditional elements are. So essentially there are different levels of coverages, and on the left hand side or on the bottom I have things that are not covered is shown in red. So whenever I write a test script, and the test script is not really going to emulate a condition where you run into this condition, it's going to flag it and say you didn't run into that condition, and it's going to put that as a penalty in the coverage. Like that, it counts all the conditions, it counts all the functions, it counts all the lines of code you cover. So it's going to track all this and give you in a nice report. Okay, so here I have this particular one, but let's go back to the whole OBSDB project as such. So here is the coverage right now for different tests. I guess this is the number, the golden number to watch for. And I could also drill down deeper to individual code. So here it says exactly what coverage I have for the different files. So all the files in that project, and it says what coverage I have. Like some files have full coverage. Often the library services that everybody depends on are often the ones for which you will definitely find unit test and integration tests. But as you start going more and more into the use cases, things get weaker. But ideally, this is something everyone needs to pay attention to and improve their code. So essentially, the system test and the unit test and the project test, they all go hand in hand. You need all of that to get it to work. And I think, I mean, so I've been a developer in OpenDaylight for a while. I've written 0 unit test, or I've written no test at all. All that I talk to you about right now is theoretical knowledge. But I did that also so that I motivate myself to start doing that. So I'm actually building an important application for the company I work in, and now things have got to a stage and maturity where I will not write one functional piece of code until I actually start doing my test framework, because it is so dangerous, and you're going to start making more and more dependency calls that you're going to actually start having quality issues later.
Also for regression, right?
Sorry?
It's also for regression testing.
Exactly. Yeah.
Yeah.
And I think there is the point of what is a POC or a demo style code, which is what I did so far, into what is going to be production quality and things that will run into in software. So yeah, I think that's my message. I mean, definitely focus on testing, and I think it's fairly simple enough. Most of the one advantage, actually, one question some people always wonder is why are there no comments in any of the files that are for testing classes? Because they're actually almost the code is a comment. Every single line actually makes a call to a function, and it has exactly what it expects, and it asserts on what it expects. So the code exactly is what logic it's going through. So typically, this is what you should also do when you do your unit test. Basically, think of exactly what you expect. Every line should be that, and you assert on every single expected value. Yeah.
Actually, I was going to ask about the Jacopo and how it works. I don't know if you can answer this. But when I was running unit tests, that was one of the first things I did to get in the code. I noticed that certain things you almost don't need to test because you're testing like the Java API or KVM or something like that. So you might not write code for that. Does Jacopo like just look to see if everything's covered, or does it look to see like things that you need to test?
I think it looks for everything, but I don't know for sure. I'll look it up.
What's that?
Every line. So you put every line function and put any missing line.
Thank you. Yeah, you look familiar now. I've seen you in the OSDB project.
Yeah.
He does a lot of testing code.
And then another question actually
It
is,
shows the display. It's like even it shows the which line missing.
oh, okay, so you should I haven't actually looked at that part. More focus on the functionality part. Sonar, I don't know how much experience anybody has here. We have a Sonar, this is Sonar right here actually. When you're writing code, say you want to actually make sure that your code is taking it or is satisfying all the Sonar rules. One way you have to do it now is that you have to set up your own individual local server and kind of import the rules from the Sonar server. You guys know this? I've seen there's a plugin where you can run a local test based on your local server, but OpenDaylight
So solar for you said
So like there's a plugin for Eclipse or Brocade where you can run a sonar test against the code you just wrote.
oh
Instead of
yeah.
having to push it, instead of having to push it and then see if you have to actually fix some.
Yeah, exactly. You are
Yeah, actually ask someone else.
I mean the question is very
Maybe something that matches it.
yeah, I'm not sure. I honestly haven't seen that before. I know that some people they manage to install sonar themselves.
Yeah, that's what I've been doing.
Exactly, and you can use that. You can handle local sonar installation and report to that sonar. Yeah, you can do. But I think your question goes beyond that. It's like
Yeah, essentially, I think what happens is the local plugin will connect the remote server and just download the rules and then run a test on the local code. But it wouldn't actually push the results back to sonar. So
but it might work actually. The only thing is you need to you need to reconfigure all these settings in the COM files and whatever the Jacob code. But in theory, if you have your own sonar, you want to report there. You want to get the same information that you are getting in OpenDaylight.
There's like a drift. There's a little bit of a variance between like what actually is in the local, even if you configure the things, and what's in after you push it over to the local, just sometimes some stuff.
Yeah, that's there, but if I remember in the past, because I have a lot of mails from since I am in OpenDaylight, I can give you some names of people that have been playing solar before, so they can answer your question.
Is there a, do you know, actually you probably know this, is there a link where I can see all the rules? I mean, Sonar actually was very valuable. I could see all the rules support, even rules style guides on. This function looks too big or too many lines in this function, consider breaking it up and things like that.
There's different ones you can click on, like the ODL one.
Okay. Yeah, these are also pretty useful. It catches errors on function naming and things like that too. Cool. Yeah, you should definitely play with this. It's sonar.opendaylight.org. Go for it. Thank you.
Thank you.
Cool. Yeah, this is an important part that we try to, encourage project or push project to get more JUnit and more coverage in this way. The white box kind of testing. It's very important too. I mean, actually, both tests are important. The JUnit white box and also the system test black box, both. Okay, so I'm gonna be quick on the last part because it's a little bit like this one, like it's more technical detail, but everything is written. So I'm probably not gonna spend much time there too. Window. So if anyone want to know more about these things, because we are presenting still. So, come on. Yeah, this one.